In Monday's video, we show you what are recursion function. So recursive function, we can use them to solve the problem. Those problems have the characteristic is they always can divide into a smaller pieces. And also eventually they will be small enough and become a base cases to direct to return the value. For example, we're using the factorial example and the Fibonacci sequence example. They both can using the recursion function to solve the result. But sometimes some problem you can using the recursive function, but also you can just simply to use the iteration. So this here, the iteration function we talk about is the function including the for loop. So the recursion function we talk about is the function always call themselves directly or indirectly. For example, did you remember factorial function? For example, the factorial function, because we know any factorial, we can convert become factorial n equal to n times n minus 1 factorial. So we implement the recursive factorial function. So that's why here we have the factorial recursion function. You pass in by the number. Then we have base cases. If your number equal to 0 or 1, we will return 1. Otherwise, we just call the factorial function again by passing by n minus 1. So the factorial by definition is n factorial equal to 1 times 2 until you times n. We can either using the recursive function to solve for that, like this. But also we can using the iteration function as well, right? So we show you this one is test factorial by iteration. That's the CPP file. So you still try to using the factorial function to solve the factorial, but instead to using a recursion function, we just have a for loop. So your for loop, your results start from 1. Then for our for loop, we can start from the number we passing. As long as the number greater than 0, we just multiply the number to the result again. Then we decrement the numbers. So then we can solve the factorial problem. So what we want to talk about in this video is sometimes some problem, they can both solve by recursion and iteration. So we want to compare the difference between recursion and the iteration. So the first thing you can see, both iteration and recursion, they are based on a control statement. So your iteration using a repetition structure, so that's your for loop. Then your recursion using a selection structure, because we either want to see this problem can be the base cases or I should call my function again. So this one we will see from here. So here when we say iteration using a repetition structure, so that's the for loop we have in factorial. You see using a for loop to control when you will stop and return the value. Then here you see your recursion function, you're using the selection structure. What does that mean? That means in your factorial function, you see you need to have either base cases or you want to call the recursion function again. So we have the if statement. If your number equal to 1 or equal to 0, that's our base cases. Otherwise, let's do the call the recursion function again. So that's the similarity for the iteration and recursion. They're using different control statements, but they all control when they will stop to get the value. So that's why both iteration and recursion function, they are involved in repetition. They just repeat in the for loop for the iteration. So recursion function, they just repeat to call the function again. So iteration using a repetition structure, recursive function, achieve the repetition actually by calling the function again and again and again. Until they reach the base case, they will return. So then they will coming back for the result. So that's why here, iteration and the recursion, very important. We need to have the termination test. That means you need to be end. For example, iteration, you have the for loop condition, right? So if your for loop condition is failed, so that's why we stop the for loop. So recursion function terminates for the base case. So again, you will see here, right? So recursion function, we stop me, function finish. So that's why we return. So that's our base cases. And iteration function, we're using the for loop. Once the for loop reach number greater than 0 is false, so I finish. So then you see I leave the loop, then I return the value. So that's either your iteration function or recursion function, they will be returned back. So when the function return back, that means the function terminated. So on the other hand, if either function, they never return, they will cause the infinitely condition. So that function never return back. Then your program will continue to run until the memory ran out. So the iteration using the counter control for the for loop or while loop. Recursion both approach the termination. Iteration modify a counter until the counter get a value you assume to make the loop condition fail. So recursion function produce the similar version of the original problem until the base case is reached. So that's earlier we say, if you don't have the termination test pass, both your iteration and recursion function possibly will occur infinitely. The infinite loop will cost in the iteration if your loop condition test never become false. So infinitely recursion for your recursive function, that's mean you never reduce the problem for each recursive code. So then they never reach the base case. So that's some similarity for the recursion function and the iteration function. So sometimes you have some problem. They can both solve by recursion function or iteration function, like the factorial. So my next question I want to ask you is, how about the Fibonacci sequence? The Fibonacci sequence, as we told you, because the definition for the Fibonacci sequence is the number will be the sum of the previous two numbers. So that's why here you have the Fibonacci 0 equal to 0, Fibonacci 1 equal to 1. They are our base cases. So then any Fibonacci number actually is equal to the sum of the previous two numbers. Because this characteristic, we are quickly to implement our Fibonacci recursion function like this. Because you have your n equal to 1 or n equal to 0, that's the base case. So then we return n. Otherwise, we will just call the Fibonacci function again to return Fibonacci n minus 1 plus Fibonacci n minus 2. That's why we have our Fibonacci recursion function like this. Can we only solve the Fibonacci sequence using the recursion function? Since earlier we talked about iteration, right? It's possible you can write a function including a loop to find the Fibonacci of n. Of course you can. So that's why here I have iteration Fibonacci. And also I give you a sample code like this. But here one thing is I want to show you in the video, how should we write this iteration Fibonacci function? So let me just remove this one. So that's called the function is iter. Okay, so we need to write a for loop for that. Okay, so how should we do that? How should we write a for loop to find the Fibonacci number? Okay, so the first thing, for our Fibonacci iteration function, right, even we don't call that base cases, but that's a special number. If n equal to 1 or n equal to 0, we right away finish, right? So that's why here we kind of still have some special case for the Fibonacci number. When n equal to 1 or equal to 0, we just return n. We don't need the for loop. Okay, so that's the first thing. We have some special case. So now continue. If n not equal to 1 or 0, how should we write the for loop? Right, I need to write some for loop, right? But also I need to define some value. So for example, you see, remember, we told you the Fibonacci n equal to the previous two number add together. So that's why here I need to define couple variable. So those variable I call, the first one is result. So result, we just have the Fibonacci n. So then I have F0. F0, that means Fibonacci 0 is 0, right? Good. So then Fibonacci 1 is 1. Okay, so that's couple variable I want to define before I start from my for loop. Because we know later the result actually will equal to the first two values add together. That's the result for my Fibonacci number. But one thing is I need to continue to do that in my for loop. So how should I do in my for loop? Right, so my for loop actually start from, you need to have a counter called I. Okay, so this I actually start from what? Before our I, we always start from 0 or 1, right? But this time, actually, I cannot start from 0 or 1 because 0 or 1, I already have the result returned. So actually, for my for loop condition, my I start from 2. Because only start from Fibonacci 2, I need to use in the sum of the previous two numbers. So that's why your for loop start from 2. Good, so that's my for loop initialization, right? So what is my termination? Right, so my I less than or equal to what? The value I pass, so that's n. So that's our condition. And of course, you know here, after the condition, then your I actually is increment by 1. Okay, so after we're done, how should we do? Right, just like I say, your result, actually our result is for the value we want to copy. So that's F0 plus F1. Okay, so that's why here you see you get n equal to 2. So then after you're done, right, supposedly we should return the result. So that's the Fibonacci number. Okay, however, we didn't finish yet because the result equal to F0, F1 is only for your I equal to the n equal to 2, right? So then I can return the result. However, if continue I plus plus, I become 3, how should I do? Right, I need to do this one again, right? But I need to do what? I need to update my F0 and F1. Because earlier, your F0 and F1 is your previous two number for 2. But now if my become 3, my 3 previous two number will be F2 plus F1, right? Right, so that's why after you finish your addition, so then when we do the next iteration, we need to be careful. We should update F0 and F1. So actually F0 become what? Yeah, F0 actually become the old F1. Right? Because you see, if you have 2, you add 0 and 1, right? But 3, you need to add 1 and 2. So that's why F0 update become the old F1. But the new F1 actually is the old result. So then we finish our iteration implementation for the Fibonacci number. So then after the for loop, right, just return your result. So then your Fibonacci number will be finished using the iteration function. So I only have 10 seconds left. So that's why here you will see your iteration for the Fibonacci will look like this.